particle of mass 4 kilograms is constrained to move along the x-axis under a single force f of x equals negative x cubed, where c equals 8 newtons divided by meters cubed. The particle speed at a, where x of a equals 1 meter, is 6 meters per second. What is the speed at b, where x of b equals negative 2 meters per second? So first they give us the function f of x equals negative 8 newtons per 3 meters cubed times x cubed. Now this formula gives us the force, which is in newtons. If you take the integral of a force function, you get the work or energy that it requires. So take the integral of negative 8 newtons over meters cubed, x cubed, dx, and that results in, raise this to the power of 4 and divide this by 4, gives us negative 2 newtons divided by meters cubed, x to the 4th plus c. Now to solve for c, we're going to use this information where it's at 1 meter, except for the fact that it doesn't give it to us in joules. So first we need to convert its speed into joules, and to do that we'll need the mass too. So we'll know that joules is equal to 1/2 mass times velocity squared. So if we go ahead and plug in our numbers, we get 1/2 times 4 kilograms times velocity squared, so 6 meters per second squared. And that results in 72 kilograms meters squared per second squared equals our joules total for that part. So now we want to bring back down our first part and plug in our numbers. So we know that the joules is going to be 72 kilograms meters squared per second squared equals negative 2 newtons over meters cubed. And then we're going to put this information in there. Since we already used the 6, we're going to do 1 meter. So times 1 meter to the 4th plus c. And we're going to solve for a constant right here. So this results in just a Newton meter, which is the same as this. This right here equals a Newton meter. Negative 2 Newton meters on this side and 72 Newton meters on that side. So we can add them together, add 2 Newton meters to both sides to get rid of that. And that gives us 74 Newton meters equals C. Then we'll come back up to our equation right here and bring it down over here. So we get that J, and then they want us to do the second part at negative 2 meters equals negative 2 Newton divided by 3 meters cubed times our x is negative 2 meters squared, not squared, to the 4th plus c, which c is 74 Newton meters. Now we already know that the units right here cancel out into Newton meter. So we're going to do negative 2 to the 4th times negative 2, which results in negative 32 Newton meters plus 74 Newton meters equals our joules. So if we go ahead and add those together, we get the joules of it is equal to 42 But if we come back up to the question, we see that they want to know the speed. Now, to find the speed, we're going to have to reuse this equation right here to convert back to speed. So we can plug in our joules, which is 42, equals 1/2 our mass, which is 4 kilograms, times our velocity squared. Now we're just solving for v. So this right here becomes 2. So we'll divide both sides by 2. And 42 divided by 2 is 21. This is a Newton meter. Once we divide by kilograms, a Newton meter turns into a meter squared over second squared equals velocity squared. And now we just have to take the square root. Square root of 21 equals 4.58257 ... meters per second. So once we round to significant digits, we get our velocity equals 4.6 meters per second, and that is our answer.